Hi everyone. Welcome back to part 2 of the TripApp series. In the last video, we covered the splash screen and how the app launches. Today, we are getting into the core of the project, the main screen, where all the dynamic content comes alive using Firebase, RecyclerViews, and the MVVM architecture. If you ever wonder how to pull live travel data into your Android app and show it beautifully on screen, this is the video for you. So let's open up the file mainActivity.kotlin. This activity is the heart of the trip app. It's where users see recommended destinations and upcoming trips, all loaded directly from Firebase. At the top, we are using view binding with a private let init bar. This gives us safe and direct access to all the elements in the activity main XML layout. No need for find view by ID. We also initialize our main view model using a private val. That line is crucial. It connects our UI with the view model, which handles data from the repository behind the scenes. Now let's jump to mainViewModel.kotlin. This class extends Android's view model and connects to the trip repository. Inside, we define two live data objects. First, the upcoming trips, and then the recommended trips. These live data lists are automatically updated whenever Firebase sends new data. That means if you add or edit a trip in Firebase, your app updates instantly without needing to refresh. That's the beauty of live data and the MVV pattern. Let's now open the trips repository.kotlin. This is where the real connection to Firebase happens. We are using the Firebase Realtime Database by calling a private val database equals Firebase database.getInstance.reference. Then we have two main functions: get upcoming trips for trip data and get recommended trips for destination data. Each of these functions adds value event listener that listens for data snapshots from Firebase. Here you can find an example. This piece of code gets all the trip data from the trips node in your Firebase database, converts each record into a trip object, and sends it back through live data. So when the view model observes it, boom, your RecyclerView gets new items automatically. Here's how everything links together. First, Firebase holds the data. Then, trips repository fetches it. After that, main view model exposes it through live data. Then, main activity observes those live data objects. And finally, when the data changes, recycler views update automatically. It's a perfect example of MVVM architecture in action. You're separating your logic from the UI, which makes your app faster, cleaner, and easier to debug. Now, back inside main activity, we have two functions: observe view model and setup category listener. In observe view model, we're observing both upcoming trips and recommended trips. When the data is received, we hide the process bars and display the recycler views. And for recommended trips, we have these lines. These are horizontal recycler views, meaning users can scroll through trips smoothly, just like in a professional travel app. So, what are trips adapter and recommended adapter? Let's take a quick look. Both are RecyclerView adapters that take lists of data objects, trip or place, and bind them to custom view layouts. In tripsadapter.kotlin, we use Glide, a powerful image loading library to load logos and images from URLs. Then we set text fields like company name, route, price, or score. In recommended adapter.kotlin, it's similar. We use glide to load travel destination, pictures, and show title like New York or Chicago, and together these adapters make the main screen dynamic and interactive, pulling real travel data directly from Firebase. Now, visually, the activity main.xml layout brings it all together. We have a scroll view that grabs the entire page, a category section with 4 boxes: trains, flights, boats, and buses, a recycle view for upcoming schedules, another for recommended places, and finally, a bottom navigation bar from the ChipNavigation library. Each category box has an on-click listener in setup category listener that opens the search activity with a category parameter like start activity. That tells the next screen which category the user selected. The reason this works so well is because Firebase handles all in the heavy lifting. It keeps your data in sync across devices and makes updates instant. No need for local databases or APIs. Firebase Realtime Database pushes the last trip into straight into your UI through the repository and ViewModel. This makes TripApp feel like a real production level travel app, even though it's completely built with a student level simplicity and clean architecture. So, to recap, in this video we explored the main screen of TripApp, how it connects to Firebase, and how MVVM architecture keeps everything organized. We saw how live data, RecyclerViews, and adapters all work together to create a smooth and professional experience. In part 3, we'll move to the search and results screens, where users can actually pick destinations, select dates, choose passenger numbers, and get real-time trip results from Firebase. If you're enjoying this breakdown, give the video a thumbs up and subscribe for more Android projects like this one. Thanks for watching, and I'll see you in the next part, where we complete the user journey with Firebase powered search and results.